Announcements and a lot of activities going on here this week. Excited about it. We are excited about introducing what we do and what we do more in the context of India. We just launched our offering, and we'll be talking more of what we do with our partners in the coming weeks and months. But today, I'd like to introduce ourselves. But before we introduce, we want to set the context of where we fit in, both in the industry trends in the ecosystem and what category we go after from an enterprise private cloud infrastructure. And then we'll get into sharing some of our partners that we work with, and then a Q&A at the end of it with a presentation from Bharat Jain and from Zetabolt. We'll have interactive Q&A on some key top 3 questions or end questions that we think needs to be answered. With that, let me start with the first. I want to thank our sponsors and our collaborators and partnerships at UC San Diego, where they have an initiative for public-private partnership at UC San Diego for AI for education, AI for research, and AI for industry. And we are one of the early industry partners. There's a newly constituted data science and data center institute called School of Computing, Information Sciences, and Digital Sciences. And we'll talk a little bit more about it downstream. But this collaboration enables us to not only work on technologies, but also look at key use cases, particularly on health sciences, because San Diego has got one of the largest health science, both hospital system as well as clinical research and variety of health and biotech research. With the thesis that fundamentally computing is going to be driven by biology and health, it's a very key partnerships that we hope to work with going forward. With that, let me step back. This is my standard slide I use in any presentations in terms of long-term reminders, what happens in technology. So where we fit in, we'll just walk through for the next 20-30 minutes about what we are doing from a systems innovation, but that systems innovation is going to be punctuated or represented in the context of where the technology shifts that have occurred and will occur as we go forward. So simple reminders are, we as humanity underestimate, we overestimate what can be done in 2 years, but we underestimate what can be done in 10 years. That you can go back in history, look at self-driving cars, look at Neuralink. I remember a slide I had put at UC Berkeley, a conference about programming languages and productivity languages, and kind of a very tongue-in-cheek thought, and you just have to think and write and get code out. That was in 2014. I'll put the slides out later. I thought it would be science fiction, never happened for hundreds of years, but guess what? You can think, you can put a Neuralink and probably have cursor generate code for you today. That I would have never thought about in 2014. So never underestimate what will happen. The big technology shifts that occur every 30 years, 15 years, 7 years. But the key thing is semiconductors drove the technology innovation in the 80s and 90s, thanks to Moore's Law. And the cloud phenomena happened in the last 2 decades. I do see the pattern now as you are innovating, as you can see, where NVIDIA is innovating tremendously from the silicon side up. And of course, there are innovations going from the top down, from the use case, from the language models, and higher order functions in AI, and both are coming at the same time together. A third bullet I would say is people who are serious about software should make their own hardware. The corollary is people who are serious about hardware should also make their own software. So I'm a hardware guy who's done software, and this venture we're doing software first, going to the hardware later, kind of reverse model. This is the only one thing I'll say about myself. My professional life has been shaped by, luckily, I didn't realize, where between 1980s and 2000, there was a peak of Moore's Law. There was an exponential part, but happened to be lucky to have been part of the semiconductor innovation cycle, having developed and delivered a number of world-class microprocessors. So today we talk about models. There are only 4 or 5 guys who could do microprocessors. They were difficult, very small teams, 150 person. If you look at foundation models today, it's the same characteristic. There are hard problems. Of course, it's a lot more money. You need $1 billion and lots of GPUs. But you still need the same 150 people to do the models. It's not like everybody can do the models. So there is a similarity between what happened in the 90s about microprocessors and what I see today in model building. It's the same level of complexity where you need the best and brightest roughly about, it's not me, it's Sam Altman coding, that it's 120 people. And you need to have them with the right resources, computing. We also need to have a lot of computing resources to go build the models. So with that, let me start. I think the next wave, and we hope to drive the innovation and disrupt in terms of systems building going forward. But the context is why it's economically interesting and valuable is, I think everybody knows, if you look at GDP, we've gone in the last 20 years from $33 trillion to almost $100 trillion. And by all accounts, the GDP could improve by 2x or 4x in the next 20 years. But the SaaS era was really a productivity improvement. So it really scratched the surface about productivity, whereas AI is going to impact 95% of work. So the TAM is much bigger, the impact is much bigger, the blast radius is much bigger than the last 20 years. That's why the computing also is needed much more. We have $300 billion of infrastructure. We went from $50 billion, I believe, in 2000 to now about $250, $300 billion of capital expenditure spend for infrastructure. So power in, capital spend. So every dollar of power you spend ends up being $3 to $5 of capital for compute, memory, network storage. And from there, you do the upper layers of software and then applications. So that 50 billion was 300 billion, but if you look at all the spending, we are already at 400, 500 billion, and all accounts in the next 5 to 10 years will be almost $2 trillion of spend. That creates, obviously, there's a big demand-supply gap. The great thing about programming is every time there is a layer of abstraction, the programming gets simpler, which means it brings more people to the party to be able to compute. I think what LLMs and natural and transformer models have done is bring everybody to be able to program. We all are logical, we are algorithmic thinkers, but not everybody could program. Finally, we have a tool to be able to program in the natural language. Your mother, your grandmother can also talk to the computer and tell what steps to take, and it'll do the steps for you, or it'll tell you what steps to do. So that's the fundamental shift, which means at population scale, you're going to have computing for everybody. That creates a huge gap. It's not even 1000x, as Jensen would say, it's a billionx, absolutely true. But it creates a big technology gap, supply gap, and increasingly, because of model and languages and data, there's sovereignty gap also that's appeared. That's the theme of the conference, so that continues to drive tremendous amount of demand. Now, we have seen a little bit of this before. I have been through the first two cycles of innovation in semiconductors in my first job as with Sun Microsystems, and then the dot-com era, and then now. And there was always a demand-supply gap in one of these transitions. But we solved it in one way. Doesn't mean you can solve it the same way, but we are at the crux of solving it also in a similar way, but in with a different set of boundary conditions, if you will. So what we solved between 1990 and 2000, if you look at, we went from clock rate, single CPU, to fundamentally shifting to multi-core threaded and distributed systems, and that was the cloud phenomena. I mean, I have a slide later to show what the transition was. I'll probably skip this slide. I think everybody knows we need lots of power, and one interesting point is I think India is going from almost nothing less than a gigawatt to about 10 gigawatt build-out, while US is going from 25 to 125 gigawatt, and other regions, and China. EMEA is going to be on a comparative basis, on a relative basis, a lot less. But the need for AI-ready geolocal data centers, we already see everybody is building out. And what is the infrastructure architecture to support that? There's certainly reference architectures inside the hyperscalers. Google has got a TPU-based, and AWS has got Trainium-based infrastructure, Trainium plus general-purpose computing. And of course, Microsoft has got Maya, and of course, NVIDIA. So those are probably, and of course, AMD. But increasingly over time, you want to have an open multi-vendor strategy. That's probably where we will talk more about. So why do I believe these transitions and distributed systems are drivers of new innovation up and down the stack? This is not new. This has happened in history. Starting from VAX 11780 was disrupted by, of course, at that time PC, but more so on the enterprise side was Sun and the workstation. If you think of the first distributed system in the modern era, it was Sun Microsystems where Ethernet was used to build a distributed system, network file system, and that was the version 1. And over time, it's like evolution. You gain more mass, more momentum, more weight in your capabilities, and you end up building big, monstrous machines in E10K. That drove the internet in the dot-com era, but that was also was an Achilles heel because that was not going to enable the scale that people had to go build at much bigger. So Google was probably the epitome of the next big shift. I'll talk about that. And similar thing we see today is we've gone from CPU-only dual socket x86 memory clusters to heterogeneous compute, but also gone through a fairly large scale up. Now, the interesting transition today versus then is training and inferencing. As you've seen the news lately with the Grok acquisition by NVIDIA and others, there's clearly a separation between the training kind of workloads and inference type of workloads and what kind of systems you want to support, because inference is going to drive a lot more of the compute. So the one way I think about it is inference and biology or workloads related to biology and healthcare are going to be the drivers of computing like it was for graphics in the 1990s. So this is back again to reinforce the point that between 1994 and 2005, we saw the shift going from the version 1.0 of distributed system to version 2.0, which is open source. So the first one was open systems in the first 20 years. And open source came and enabled a new way to build distributed system because from an economics, it removed the cost of middle layers of software. Everybody got access. In this case, Linux versus Solaris. But that also enabled to build truly hundreds of thousands of machines in a single cluster. And out of it came Borg, Kubernetes, and a whole bunch of other distributed file systems, all kinds of innovations that happen. So the proposition here is, I think we are at the cusp of similar things on the inference scale compute as well. Yeah, so just a reminder. And the punctuation that happens every time turns out to be, if you look back in history, is Ethernet. Yes, the network is the computer, but more important is 10 megabit was the onset of replacing big mainframes or mini frames like VAX to workstations, a network of workstations. Then right at the point of 10 gigabit Ethernet coming around 2000 to 2002 timeframe, along with it was multi-core, was enabled the new distributed system, building block. We are at the same point. We've got 400 gigabit Ethernet going to 800 gigabit Ethernet and probably a terabit Ethernet networks. And that's hopefully, and that will be the enabler, and that's a bet we are making. So the other element of the system is its network and then the memory. And do you build a full scale-up system at data center-wide? Certainly you need for training, for backpropagation and forward. But inference can be much more distributed, shardable, and it's time to rethink what kind of systems you want for inference-only dominating infrastructure. The other dimension to think about is we've gone from a single memory type to multiple memory types. So do we need 4 light types of memory to deal with variety of layers, or just 2 or 1? That's a lot of debate in the technical community, but that's a critical decision that will happen. So a way to think about is we think of the entire system not from flops and GPU and compute. GPU compute, CPU compute are needed, but really what does the memory hierarchy or memory system look like, because there is a physical view, because that dominates the cost function and the power function. But equally at the same time, you have to represent that, especially from a performance standpoint. You are caching lots of different data for computing. So it's think of the KV caches for the LLM side, the in-memory representations of many of the data from a performance standpoint. So that's a layer that is rich in innovation and technical innovation that we hope to have an influence as well as probably make a mark. And then the large part is the logical view of memory, especially deep context. You want to go from session to session, location to location. You want to have your memory state. You want to be able to switch models and have some state of the memory state. All of these consume various layers of the logical and the physical layers of memory. So that's where we think about. So putting all this together, we think of taking a bet with Ethernet, taking a bet with memory, and build an infant scale compute for population scale, like in this case India, but also in certain key verticals like health sciences and others. So there's another important element we want to highlight. I take a quote from Jensen, where he talks about inference at scale is extreme computing. I'll just show a small clip. It's not just inference at scale, but what does it mean in terms of...
One of the applications that my favorite is just good old-fashioned data processing. Structured data and unstructured data. Just good old-fashioned data processing. Yes. And very soon, we're going to announce a very big initiative of accelerated data processing. Data processing represents the vast majority of the world's CPUs today. It still completely runs on CPUs. You know, if you go to Databricks, it's mostly CPUs. You go to Snowflake's mostly CPUs. SQL processing at Oracle, mostly CPUs. Everybody's using CPUs to do SQL, structured data. In the future...
So, taking a cue from what he's saying, historically, databases, SQL, all run on CPUs. And that'll remain the case for a variety of reasons. So that's an important metric in terms of why we believe the new systems that we compose going forward needs to have a happy blend, especially there are ways to design systems for the hyperscalers, but there's a whole category of use case and customers in the private side where they don't need to have 100,000 machines, but smaller scale machines, but it needs to have a happy blend of CPUs and GPUs. That's the main point in terms of... So in that context, we have taken a position to start working in partnership with AMD because they've got the x86 CPU assets and a compelling GPU roadmap, as well as an architecture that supports both from the network side as well as the memory side. They have higher memory capacity for LLMs. So it started with 256 gigabyte of HBM, which supports 128 billion parameter models at least. Now it's going to go to 288 and 512 in no time, which means we can fit fairly sizable models. So that enables one to do more kind of classical distributed systems, principles of single node that captures most of the workload for most customers and be able to optimize around that. So coming back, before we get into what we do in Proximal, I want to emphasize the partnership with UC San Diego. They have a data center, as well as I told, it's a supercomputing data center for research for NSF and DARPA, where we are doing some of the work in terms of the hardware level at the middle layer, in terms of the compute kernels, as well as in the inference engines, as well as the use cases, as I said, because there's a data science institute, AI for education, to transform the undergrad and graduate level programs using the same tools to have advanced research capability, as well as for health sciences. So with that, I think that is a part to set the motivation for what we're doing in Proximal Cloud. The next phase we want to go into specifically what we are launching in the 4 layers, the key components of what we have building and delivering to many cloud partners in India, to starting with. There's also a why India question. I think I'll say one aspect is India demands an extremely low-cost infant scale compute at population scale, and that's a challenge. So we really are excited to work on that problem to start with. So the first thesis, why do we need compute other than the cloud? I think the best way to quote is Michael Dell telling you what he sees.
To the beginning here.
What can you share about on-prem AI deployments, Michael? Are you seeing anything interesting there?
Yeah, so we in the last year, delivered a little over 3,000 of these Dell AI factories, and those are increasingly to enterprise and commercial customers that want to bring the AI to their data, not the data to the AI.
Yeah.
And, there's just a ton of data that is still on-prem and being generated on-prem. And it turns out to the beginning here.
So Michael Dell sets the stage. 80% of the data is still on-prem. Imagine you have your old 1960s cheat sheet or paper invoice or something that you have. You can scan it today and digitize it. I mean, you can see a lot of historical 3,000-year-old manuscripts are being taken, scanned. I saw from Sarvam yesterday. So no data, any piece of writing, any piece of information that is available in recorded history can be taken and be put to use. That's a fundamental value prop that AI is giving that prior computing era has not given us, which is not all of it will ever go and be in the public cloud. All of it is in the private side. So really need to have a modern compute infrastructure on the private side to unlock the dark data. So to deliver the value, we have 4 layers. We talked a little bit, touched upon the hardware side. I don't want to go for today on more details on what we do on the hardware. Suffice it to say that we are working with key partners, working with CDAC. I have a long history and relationship with them. Being at Sun Microsystems, their first Param supercomputer was also built with some of my chips back in the late 90s. And it sort of life comes back to me to go work with them again. They've got the Rudra 2, Rudra 3, and we're working with them on AMD and NVIDIA-based platforms to realize for the market later this year, as well as a couple of other partners we'll announce later. But the interesting areas where we differentiate, innovate, and bring to the private data, which is not existing today, is a rich data infrastructure. A data infrastructure is not storage, just file blocks and objects, but really to be able to take all of those data and represent, we got to do the cataloging, the indexing, the ability to search, higher order functions, and then from there you do take actions, etc. So in cooperation with UCSD, we have a rich distributed data catalog infrastructure, and we have partnered. We got a deep lake where the backend is an S3 or object store storage tier. Is being proven and working with many health sciences, and soon at UCSD as well at petabyte scale data ingest. So we want to simplify the ability to ingest the data, index it, search it, and represent it. But it's not enough to just index and search. We want to represent, quote unquote, an AI memory layer for the upper layer functions, for the agents, the compute, for taking actions. The next layer above is all the AI operational infrastructure, which is pick and choose. Well, one of our partners here will talk about Divyam, about how do you do model selection and model execution and runtime. All of that is taken care of for the user in the back end. We have assembled the entire reference stack. There are innovation points we do. Some of it is open source. We have our key microkernel that does the resource management and the compute. We are really a compute company on highly distributed variety of data types that exist in your on-prem. Could be video, could be time series data, could be audio clips, could be OCR information, all of that. Now, any of it can be dumped into a deep lake, could be a searchable index, and then represent for higher order functions from there. So, in principle, in a way, in a sense, we have 3 broad product categories. We have the hardware reference design that we think will be useful for small and medium enterprises, and maybe even for mid-market companies. But if they run out of compute capacity, we have partners that we'll announce later that they will have the same compute, same stack available in one of the clouds providers here. And the core, the middle layers, which is the data memory and the memory-centric resource management, is our compute AI kernel infrastructure. On top of it, we are actively now building the deep context and personalization that's needed for any individual use case and application. So just to give you a sense, maybe I'll get to that later, sorry. So as I said, we have a on-premise appliance which will be air-gapped and a cloud partner. Both will be available in any one of the neo clouds, starting in India as well as in the US throughout this year. Our ingestion layer is, we have all the connectors to be able to connect to a variety of data sources. So the idea is to be able to go into an on-prem customer, enumerate the data in conjunction with their IT or their data management teams, support all the security and the guardrails constraints for the data to be not leaking out. That's why sometimes an appliance may be useful. Ingest the data into a deep lake and be able to have a searchable infrastructure on day one. So that's from there you pick the both for structured. So the challenge or the challenge and the opportunity that exists is not only being able to take unstructured data and do RAG. I think everybody does that. But to build variety of causal relationship, for example, you could ask a query is what was the impact of Trump's tariff on steel in April 2025? So you have to ping pong between what is in your database, in your SQL database about what is steel prices, what is the tariff, who is Trump, blah, blah, blah. So all of that is taken care of in the backend in terms of being able to parse the query, go to different subsystems, and more interesting is to build the causal relationship between the structured and the unstructured side. And that brings in additional computational complexity. We are not training the models with the SQL databases. It's also a way to keep the databases isolated. We can query the database. And the lingua franca for computing is English, but the lingua franca for data systems is SQL, right? So it's basically a SQL engine on steroids that can go inquire these data systems and assemble the answers back for the end user. In the AI ops and the model orchestration layer, we'll talk a little bit about that in more depth in the model selection and model execution and orchestration, which gives us higher order optimization and give over time, as the system runs in the background, optimizes for the customer, for the use case in terms of the model type without trading off quality, but save money typically. The final point and the important point is deep context. Many of these pieces are available in the public cloud, but it's not fully assembled, put together, and made it cost efficient. So we have a thesis around delivering cost, better outcomes, deeper insights at the lowest latency and a more scalable solution called coils. So, and this is where it comes in is to get deeper context. Retaining the context and deep personalization is extremely valuable. So at the agentic layer, the layer 4 of our stack provides, which we call Crania, provides deep context personalization, enable deep research, and high throughput. I'll show a little bit demo of the deep research part. I guess we are here. So this is an example we are working with UC San Diego and providing for AI for education. So think of this is not a K-12 school. This is a graduate school. And they're students or faculty doing a lot of research work. So getting peer-reviewed papers, getting the knowledge search. We have taken, let me see if I have, we have taken about 25 million papers in archive. It's about 100 terabytes of data and index and search and provide that as a capability in a service. A simple thing I'll show here is, I was just doing this earlier, maybe somebody has a question to ask about, if you know of a technical paper or something to ask, let's see if it gives the answer. Any question from the audience? No? So I'll ask who were the... I know, let's see what it says. That's a pretty simple question, but once you get the answer to that, attention is all you need. You get this paper, you can go reference. I guess it goes to the wiki page. Then you go deep into each one. So imagine a student having access to all the 25 million papers and doing their work. To be able to go at a granular level, at a paragraph or a table level or a visual or a graph level or a image that is embedded in the paper to be able to get information and reference it and use it in their research work or class work, if you will, right? So that's the capability that we bring in to, in this case, the higher education program. So in a brief way for the AI for education is we have rich data services. Layered on top is this complex high-performance compute that takes relational data, unstructured data, knowledge graphs, and of course LLM information, and give you better answers. Yeah, the same answers will come. We can go back and go more complex one for papers. I just did a simple one for demo. We can go back into that. I mean, here I was asking a different paper. We can go into a paper and ask a specific thing about the paper. Let's say, if you want to, let's see here. I think, as I said, that was a very simple question, no doubt. Okay. The point is, I mean, I don't have time to show the demo of being able to look at all 25. If you are a particular question in a domain that you understand, we can try it out. Okay. After this, sorry. So we enable with this interactive learning for the students, contextualized intelligence, and of course, instructor empowerment in that. And the way the look and feel will be like a Jupyter notebook. With on the extension side will be the research content, the archive papers for them to use. It's an add-on thing. It doesn't have to be integrated. It's a conversational AI chat, if you will. Then the next example would be MRI images. Unfortunately, I'm not able to log in remotely onto that right now. The other one I had a local copy. I'm not able to show for MRI images right now. So at this point, I want to summarize saying that what is Proximal? The word proximal we bring compute closer to your data. The word proximal means it's sovereign to the nation or the region or the business that cares about it. And the word proximal also means we bring compute closer to memory, we bring compute closer to where the business is. So that was a thesis. We are not doing this alone. We're doing it with some technology partners, as well as we have some key customers and partners. So with that, let me give an example I give you an education use case. Let's go to, I'll bring Lalit Bhatt here to talk about who is director here heading the India office for Pharmex, as a key partner.
Thanks, Renu. So what I'll do is, and thanks to Proximal Cloud for giving the stage out here. What we'll do is that basically first I'll little bit talk about what Pharmex stands for, and then why in this space and different space, why local compute and all these things are becoming important. So Pharmex is basically a comprehensive AI stack. So if you see on the left-hand side, we have a lot of in-field sensors. So we have a complete comprehensive platform in terms of not only soil moisture sensor, but dendrometers and multiple sensors. We also have imaging capabilities where we can take images using satellite, using drones, and we also have an autonomy stack, and we just now have acquired an autonomous electric tractor. Basically, and these are pretty big machines. They might look like transformers, but these are like almost 70, 80 horsepower machines. And we are putting our autonomy stack here so that they will go completely as autonomous one. So what I'll do is that I'll just run a small clip. What Pharmex stands for, what the target we are going after. We everyone understands why we need that we can integrate into the platform and complete so that you can manage this whole farming wherever you are. So some of the things that I'm just showing that just to give an idea about how comprehensive this is. We have seen clear results with Japan. Okay, so I think then let's get back to the theme of today's, which is like local compute and why it is important. Again, I think this is probably very standard. Everyone understands this. You need to do AI, you need data. These two things, we need that one. Then what becomes important is how efficient you are in terms of running those inferences using those data. And we are also dealing with huge amount of data, and that's where we are looking into this technologies where we can reduce our cost. Everyone understands that in agriculture it's very very difficult to ask a lot of money from the farmers. So where we can really make our operation more efficient is if we start like making sure that we are very efficient, very effective in terms of dealing with a large amount of data and able to run inferences on top of that one. But essentially that's what happens. We get a lot of data, both from the imaging side, both from the sensor side, and then we have our all engines running, which basically leads to diagnostic and recommendations. And this is just an example of the kind of things that we do with our customers. You would see here like complete or autonomous irrigation scheduling. A lot of data points would go into those models, basically to create those schedules, anomaly identifications, crop stresses, yield predictions, frost predictions, and even we have worked on this soil percolations model as well. Yeah. What is the cost? It depends on what all sensors you take. So in India, I can tell you, like we sell one, there's 2 feet force sensing probe, which is like force sensing, it goes 2 feet one. And with the whole controller unit, it's at 45,000 per unit basically, per unit. Usually in India, we recommend 1 unit in 1 hectare. But again, it will change based on the variation of the soil and these things like that, but this has been a good ballpark basically. Okay. So yeah, I guess that's it. And I think the whole theme is that we also are looking for really reduce our inference cost, and that's where Proximal Cloud comes into picture. Thank you.
Thank you, Bharat. Okay, next we'll have Bharat, Director at Divyam, who is a key partner in, as I mentioned earlier, about model selection and runtime optimization that is integrated or will be integrated into a stack. So, Bharat.
Hey, good afternoon, everyone. So let's address the hard truth out there. 90% of GenAI pilots never make it to production. Not because the demo was bad or the models were weak or bad. It's primarily because of 3 reasons. Number 1, quality is undefined. What's good for one use case is not necessarily good for another one. There's no standardized way for evaluation or regressions. Number 2, the costs are unpredictable. Be the cheapest model or the best model, you can see the price of these models ranging differing from like 10 to 50x. The moment your application goes into production and hits real traffic, the costs spike up. There are AI engineers who are running experimentations and trying to tune this, but model selection is always a moving target. There are always new models coming which are trying to fix something, end up breaking something else. So without addressing all 3, it's very difficult for an enterprise to take their pilots to production. And that's why we built Divyam. So Divyam is the only inference layer built on quality. Divyam defines measurable evals aligned against each use cases, and it optimizes every incoming query to select the model which is giving you the best quality per dollar. The other part is that Divyam automates the entire model selection process by continuously evaluating new models, deprecating the previous older ones, and migrating you to newer ones. If we find something better, we auto-upgrade without breaking production. Evals first, routing second, and that's what makes like Divyam different from every other routing platform out there. Divyam is the only inference layer with customer-specific intelligence. Your apps can be AI agents, RAG pipelines, or multi-agent workflows. And the LLMs can be from the standard OpenAI, Anthropic, be your own fine-tuned models or deployed open source models. We sit right in between. We provide you a single API. We are continuously evaluating each and every incoming request, routing it to the model which is giving you the most optimal performance, and also giving you detailed visibility on what models are working, how is your agent performing, and what's the overall quality. Remember, Divyam is trained on your data, your agents, and your quality eval. There's nothing generic out there. And this is just not theory. We've already proven it across multiple deployments. For the India's largest travel aggregator, which runs a conversational shopping assistant in their application homepage, we were able to cut down the cost by more than 60%. For one of the leading e-pharmacies of India, the customer support chatbot had a little bit lower latency. So we ended up improving the cost by reducing the cost by 30%, reducing the latency by 30%, leading to a case resolution improvement of 95%. As you can see, different use cases, different industries, but the result is the same: lower cost and better outcomes. And we understand enterprise realities. You can keep your data secure. We have flexible deployment options, be it SaaS, privately hosted, or on-prem clusters. You stay in control. If you're trying to take your Gen AI pilots to production, feel free to reach out to us. Yeah.
Thank you, Bharat. So we talked first about application use case, one in education and agriculture. Second one, how we are bringing optimization of the system stack. Some of it we do and some of it with our partners. Third, we want to bring in how do we get customers, many of them mid-market, small, as well as large ones, enabled on our platform. I'm happy to introduce Sandeep Kumar, coming as part of Venture Builder Instances, is a company that we partnered with in Delhi here to take this to variety of customers, small, medium, large, with a higher velocity. Let him describe what they could do and how we partner.
Hello, everyone. I'm Sandeep Kumar from Instant System. We are a Silicon Valley-based venture builder. We do not just build startups. We grow them. We are partners in every domain of a startup, be it engineering, be it product, be it marketing. We just give them full bill print to be a successful startup. We co-invest in the startup so that we are there in every journey of them for them to be a successful startup. We are a venture builder. Sometimes it's often confused with the incubator, but we are a venture builder where we actually help in the every step of your startup to be a successful startup. Part of the Instant System, I'm mostly responsible for a company called Vanai, though we usually do not disclose the name of the company that we are partners with to protect the IP and the confidentiality, but just to give you a use case that what our capabilities are and what we have been able to build so far. So this is a use case that I'm taking. This company has got nearly around $200 million funding from the top investors, including SoftBank. We are building an AI conversational software here, and we are dealing with real use case, real challenges of for mostly like financial domain or financial-based industries, but all of these solutions are also generic for the analytical-based industries as well. So I'm going to talk about some of the challenges that are actually common to every problem or every AI-based solution. But we've been able to identify these challenges and we've been able to solve these challenges for this particular use case. So one of the most challenge that every AI-based software face is hallucinations. So LLMs always try to answer to your question, irrespective of how much of the context it does have. We've been able to solve this problem up to a very good extent. Our system is almost 99% reliable. They do not hallucinate. That was the biggest problem that we've been able to solve. Next challenge that we face is disambiguation. So in spite of providing the context, sometimes the system are not able to understand how to disambiguate between some specific terms which may exist in different domains. So that's also the problem that we've been able to solve. As the theme of the system, and it's very closely related to the theme of the system, because data security and the data privacy is one of the major industry concerns that we've been able to solve. So we've been able to address and challenge this problem so that the data privacy and the data access control is being managed at the row level, or in a very technical term, I would say at the object level. We've been able to tackle that problem and solve that problem efficiently and that's already running there and working fine. Evaluation and the quality management, that's also one of the key area that we need to solve as part of the the venture that we are building. That's also that we've been able to solve very efficiently. Another thing is the reliability, because since we are talking about the financial system, the system has to be reliable. It has to be reliable every time. You cannot send $1 million to someone's account by mistake. So that doesn't work in the financial world. Or you cannot report data where you could show losses instead of revenue, or vice versa, because you cannot survive in that world with hallucinated or the data which is not correct or factual. So being able to with our advanced architecture system, we've been able to solve that problem as well. There's a long list of the pointers that we've been able to solve, but I just cut down short. The system that we've been building are performant, they're reliable. We've been able to keep a check on the cost and efficiency of the system. That's how we've been able to serve to the different audience, different customers from the different niche. So that's what our theme is. We are a venture builder. Please feel free to reach out to us, and we'd love to talk to you about your startup. We though pick selected startup to work with, but you all are welcome to reach out to us, and we can discuss all the stuff that we are working on. Thank you so much.
Thank you, Sandeep. I think that ends what we're doing in Proximal and what our partners and our customers are working with in early phases. We have partners in the US like UCSD on life sciences, health sciences, education, and here in agriculture, and soon to other. Particularly, we're going to focus more on, it turns out to be that the Government of India initiative of education, health, and agriculture coincidentally aligned. It was not planned, it turned out to be that way. With that, I can go back to any questions. We've had a small panel session we can go to. I don't know if Piyush has come here or not, but I think there's a question here from Arya from Infosys, Senior VP at Infosys. Please.
Hello. Excuse me. My name is Arya Bhattacharjee. I'm from entrepreneur from Silicon Valley. So right now, like Renu said, I'm driving the semiconductor and AI vision for Infosys from the United States and in India also. So the reason I'm here is because, like Renu said very correctly, a very important question that what's in future for India? How can India capitalize or make a mark in this journey? So not a small answer, but I can tell you what we are trying to do at Infosys. Because if India is going to win this Semicon 3.0 or 4.0, 2.0, no, I don't know, it has to be in software, it has to be in AI. The chip building wise is going to take some time. So Renu said that 80% of the data is on premise. And what we are working on together is to see on the semiconductor place, this is true, absolutely true. More than 90% of the data is on premise. So the whole journey of how to take that data and how to create solutions through agentic AI approach, through distributed computing, and actually by owning the architecture to lower inferencing cost is a main challenge. So to answer the question which Renu asked me, what's the future of India? I think the India, what we're going to do is we're going to look at a domain. So at Infosys at least, we have selected domain. And semiconductor, I was talking to him also, that is a large domain. And we have taken the leadership with some major clients right now. I can't talk about details. We're using an agentic AI on premise and delivering productivity solutions, AI solutions, and by cutting our productivity for chip making at least by 25%. And every day in a semiconductor fab, you save $10 million. Benchmark for a 7 nanometer type of technology, not even 1.9. So with that, good luck to Renu, and I look forward to collaborating. Thank you.
Thank you, Arya. Now I welcome Abhishek Ranjan, but before, just come on board. To summarize what we do,
graph
this is the best summary.
that is underneath what I think is the most important AI factor. So organizing the data layer turns out to be probably the most complicated thing, which spans the enterprise such that it can meet the intelligence. And so that's the stuff that I think we'll probably do a lot of.
We still don't really have deep research in a corporate context.
We do. That's what Copilot is about.
But most people day to day do not have this. So are they just underusing AI that exists?
Yes, in fact, it's interesting you brought that up, because to me that is the killer feature, right? So the biggest thing we did was we took this graph that is underneath what I think is the most important database in any company, right? Which is underneath your email, your documents, your Teams calls, what have you. It's the relationships that, by the way, own AI factors. So organizing the data layer.
So that's the best summary. Obviously, Satya wants to do it in the cloud, and that will happen. But also you need to have it in your on-prem and near-prem, isolated from other be sovereign as well, and have the same capabilities. In essence, that's what we bring to the enterprise, if you will. Any other questions before we go to a panel session?
You can actually have the mic. You can speak here and you can answer in the mic.
Why do you both ask?
Thanks for having me here. This is Abhishek, founder of Zetabolt. We did a lot of work on the LLM acceleration. What it means is that we offload the large language models to the specific chips and custom silicon, and thereby get the inferencing speeds and all. So we have Renu here, who has like wealth of experience on the distributed computing side, and like we were supposed to have the panel discussion, but I thought I would pick his brain on what the challenges and what kind of changes he has seen in the industry. So Renu, like you have been part of like Sun Microsystems and early sort of like pioneers of distributed computing. So from Sun, which was maybe the distributed systems 1.0, to Linux, which pretty much democratized the entire computation space and brought the Linux and x86, and now almost every embedded device, every computation pretty much happens on Linux. So that was the distributed systems 2.0. And now coming to the distributed computing space with the open models, right? Open source has played a lot of sort of role in the proliferation of the distributed computing. What do you foresee, or what do you envision the open models are going to do for the distributed computing? Are we going to see a distributed computing 3.0?
Hello. Yeah. So that's a fundamental thesis and bet. I mean, we are, in a way, in part of that continuum to some extent. If you look at, not to take anything away from how NVIDIA designs, but there is a clear bifurcation going on right now as we speak on, as we said, training versus inferencing. And then there is open source models, and variety of customers' use cases would use and need the open source models. There's always been the history of open and closed in every transition. I mean, if you go back in the 80s and go back, I mean, if you look at what enabled the cloud was hypervisors, there was KVM and VMware. The same thing will apply. There will be open models and closed models. But the way I like to think about it is models as a new abstraction layer that separates between the underlying computing needs and everything above. Hypervisors separated the physical machine to a virtual machine, and then operating systems, Unix at that time, also did that. The same thing is models are the abstraction layer that provides a higher degree of innovation, both from closed and open models. The closed one will probably be innovated within OpenAI and Google, but the rest of the world will take the open source model, like what happened with Linux, and innovate. It's not just going to be an NVIDIA GPU or AMD GPU, or there could be a plethora of GPUs, country-specific, region-specific, domain-specific, anything can happen over time.
That's a very wonderful take. one of the things that we have been wondering is about the latency you talked about in the various scientific and other applications you're working. When we build the solutions for our customers, we build a lot of actually natural language to query processing kind of solutions. We have been able to do maybe a sub-minute kind of a solution, which is acceptable to the customer because from weeks or days, he is able to answer or get the answers to their queries in less than a minute, right? But even a minute is not sufficient, right? When you talk about really interactive queries and all, you want sub-millisecond or maybe sub-second kind of response. What are your thoughts on that? Is it even possible that to a population or to a large customer base that we have in India, about 1.5 billion people, at a very low cost, maybe 200 rupees per month, you can provide query processing at a scale which is within sub-second?
I think that's a very good question. Sometimes stating the problem is more important than the answer. This is an interesting way to frame the problem is, if you go back and look in history, why did Google succeed? A fundamental decision that was made by them on the toolbar is every query response has to be in 20 milliseconds. Now, nobody thought about it prior to that. It's obvious today. But that key proposition or definition or the question that was asked, maybe by Larry Page or Sergey Brin, whoever it was, led to what we see as Google today in the back end, which is a huge amount of infrastructure to satisfy the 20 millisecond response to any query. So to me, the same thing applies today. Maybe 20 is too hard. I'm just arbitrarily pick. I have a simple demo or animation thing I was trying to show is every 120 milliseconds you want to have the answer. Today, if you go ask a question, it'll take seconds, sometimes longer than that. We are all impatient. We want the answer in quick order. When I ask you a question, you don't say, let me think and come back. You want to give the answer. If you don't know how to think and back, okay, you can, but that's a very deep question. You can think and come back, but we can throw more computing resources to get that. So what it tells you is you can throw a lot more computing to get to the answer. It's not just hardware. It's going to be algorithmic improvements, other improvements. But to me, that's the benchmark. Get to 120 millisecond to any query for anybody. And why? So there's a global context and India context. India provides an ample opportunity for 1.4 billion people. If you can deliver at a cost point, like 200 rupees a month at 120 milliseconds, and any query to be handled, which is a long road to go. But if you can meet the objective in 10 to 20 years, it serves a lot of people, but it also will drive tremendous amount of innovation. So that's why when somebody says population scale, India has a unique thing about the population scale problem and the cost problem. So hopefully there are enough people within, as Arya said here, Semiconductor 3.0 and other innovations that can drive to build India's own sovereign, lowest cost, shortest answer to any language to the question that you asked.
Interesting take on that. One of the things that keeps coming is about the scale of the global corporations or the size that they have been able to reach. With AI gaining mainstream in India, and there is a parallel actually theme going on, which is on the semiconductor side, right? The government is putting a lot of focus, private players are putting a lot of focus. We have in the audience esteemed our Infosys guest. And the question that everybody keeps wondering about is with the AI and AI is speeding up things, is talking about productivity gains and all. Can we, what kind of corporations can come out of India? Can we see NVIDIA's coming out, or I don't know, Palantir or Supermicro, or even a new version of Sun Microsystems coming out, just because there is so much emphasis on AI or the semicon side? I'll let Renu talk, and then maybe you can also have your take on this particular question, right? What kind of corporations can come out, right? Your take.
Yeah, before I get there, I forgot to say one thing in the prior question is, India provides the cost and infant scale compute. The other one dimension that also is going to drive compute is biology and health sciences. And both of these are going to drive innovation at the systems level. Now, coming back to category companies, right? If you go, Y2K created effectively Infosys, TCS, Wipro, and all of these companies today, right? So every big transitions cause new business models, new companies, new categories, new technology stacks, everything happens. So suddenly we are in a disruptive mode to challenge incumbents, which is a good thing, and new companies have to emerge. It could be in the same categories that exist up and down the stack, could be in the application tier. I remember 20 years back walking around streets, every lamppost used to be SAP trained. Everybody used to get trained, and that was a job. Everybody had a badge of honor if they got an SAP trained in their thing and then go get a job. I used to think, why are they doing this? Now I think about it as saying, with this fundamental transition, can there be an SAP coming out of this transition in the AI? Why not? To give you some raw numbers, every gigawatt of power will require $25 billion worth of compute memory network storage. So if India is going to do 10 gigawatts, that's $250 billion of hardware. That brings multiple supermicros, or that sustains a semiconductor ecosystem at that scale, right? So certainly the investments going in for power, which is a long lead item, is important. But the next layer provides the economic value to host the hardware systems company. The HP, the Dells, and Supermicro can emerge. You can go each layer of the stack. The next layer is the application engine tier, where Proximal is that. Maybe we could become the SAP of tomorrow. That could be a Palantir, which is the application tier, not just Palantir, any other company. So both the scale, and if you can solve the technology, the scale, and the cost economics, it's not just restricted to India, it can be global. Unlike the China model, where it ended up being a very closed garden wall, I think India has the opportunity to be make in India and make for global is much better, but you just have to think bigger, more important is take bolder bets and go for the long haul, not just work for it for 5 years, 7 years. These are 10, 20 years cycles to change.
A very interesting take, and thanks a lot for actually, and I would like to have your opinion on this particular question. Do we see NVIDIA's, SAP's, and Oracle's coming out?
Thanks. So I think the semiconductor data, for example, recently working with one of the large companies, I want to give some specific examples. They are just ingesting data right now. I'm talking about a fab, not design. They have got 7 petabytes of data ingested and they don't know what to do with it. And like I said, a typical fab manufacturing facility is worth at least $10 billion. And it's got thousands of steps. And it takes over 120 days to make a chip. So $10 billion for 120 days producing a wafer, and there are defects, design issues, things. So if you take that data just from basic information, runtime, real-time data, defects, soft defects and hard defects, because just because a chip fails doesn't mean it's slow. Slow means no money. That's a failure. So collecting all that data, classifying the data, understanding and using agentic AI agents in an edge computing way. You cannot solve this in a server. And then feeding it back to design infrastructure. So the design time also has shrunk a lot, and the yields are going up. When 30 years ago, when I was in Intel, we were talking about die sizes of like maybe 1 centimeter by 1 centimeter. Today, in a 300 millimeter wafer, NVIDIA's latest wafer level chip is about 20 centimeter by 20 centimeter. That level of yield and reliability is unimaginable without the use of AI. So I can go on and on, but I think if India has to win, I don't think India needs to become a Palantir. And India does not want to become a slave shop. So the way I explain that in a one-level page, that Palantir's gross margin is 95%. Indian company's gross margin is 30%. Can we build a business at 50% gross margin where the amount of domain expertise India provides with the amount of data is available to take these technologies we talk about to implement them in real practice? That's what India can win. It is the execution with the best technology. Thank you.
Thank you, Arya.
Thanks, everyone. I have one question for the venture side. Right? So, all these technologies, they require a lot of investment before they can actually become fruitful, right? I heard somewhere that the government of Karnataka, and I don't want to demean them by the way, I put like 20 crores of fund for actually funding the startups and all that, right? The single engineer which actually Meta is hiring right now, they are throwing how much, like $100 million at that engineer? 20 crore for funding like hundreds of startups versus $100 million like being given to one engineer, right? There's a huge mismatch. Now the question is, do we, like for Indian companies, do the venture capitalists or the private equity, do they have such deep pockets to fund them for like continuously fund them for hundreds of millions or billions of dollars so that an NVIDIA or AMD or I don't know, like the Sun Microsystems can emerge? I want your take. Answer this question.
Actually, so
Renu, like I would like to take your.
I don't want to answer. I want you to answer the question. Answer your own question.
You want to answer my own question? Yes, it will require that kind of investment, right? I think this was one topic I touched upon a long time back. ISRO has been funded like continuously, right? Initially, the ISRO rockets would all land up in the ocean, right, or the sea, or whatever. But over a period of time, they gain competence. They are among the top 4 in the world right now, right? I think that kind of like continuous and continued support is needed for whatever industry we are picking, whether it is AI or whether it is semicon. Like we need the private players, we need the government to support it like till the end, right? And that's when maybe the key players and the winners will emerge.
I think your question has got two parts. Sorry, there was a public announcement. That's an interruption here. I think there are two parts. One is there's a mismatch between what a demand-supply gap and skills in the model companies, if you will, to what a person gets here, and what is the kind of investment that is needed in that. I think the demand-supply gap will always be there because the extremely good talent are always in short supply. The question is the engineers in DeepSeek are paid the same as the guys in the Bay Area?
Probably
right?
not.
Clearly not, right? So there is always going to be the regional bias and all that. Sorry, there's a public announcement going on.
In the meantime, if anybody from the audience wants to ask question to Renu, feel free. Otherwise, after this reply, we'll close the session.
So the reason I asked you the question is because you are one of those smart, brilliant engineers who decide to stay back and not do the same thing. And if you were in the Bay Area, you would probably be one of those $10 or $50 million engineers.
Hopefully, yeah.
So why did you do and what do you think? That's why I asked the question back to you.
Yeah, it's good. It's fun to build for India, by the way, and build from India, right? Build for India, build from India. That's why we are here. And that's why all these conferences here, all the discussions are happening. But thanks a lot, Renu, for all the wonderful insights. Last call, anybody from the audience wants to ask any question to Renu?
Yes, sir.
Why don't you have
Thanks, sir. So my question is that you shared that if 10 gigawatt business comes to India, that means $250 billion worth of equipment will be purchased or something will happen in India. So how can we ensure that 10 gigawatts, just leave 10, let's start with 1. So how will that business come to India?
How will that?
I'm just sharing that if 1 gigawatt business, you said, will come. So how will that business come?
How will that business come?
Yeah.
I mean, today, we already see most of the hardware is either brought in by the hyperscalers who got some capacity, and then Dell, HP are the largest OEMs as I understand. Supermicro is behind, and I guess most of the hardware level systems are manufactured in Taiwan and other places and brought here. And there are emergent players like VVDN. Sanmina has got a manufacturing plant in Chennai who's going to come and do Make in India. I don't want to steal the thunder. So there are emergent ones seeing the economic value of that scale to start designing. But we've already seen, I don't know the details of all the phone manufacturing that's happened. So the ecosystem of building chassis systems, board design capability was there, but manufacturing manufacturing and operations support and all that was not there. So I do expect that to start happening. That's why we started working with CDAC and VVDN to some extent. We do see the opportunity that there's at least a $300 to $500 million opportunity. If you look at, the interesting thing aspect is the Indian public market is also valuing these things fairly high. Look at NetWeb and others. So you can't go and raise money in the public market for these kinds of businesses in NASDAQ. You can certainly do that in India. So it's an interesting point in time where there's a demand, there's a need, there needs to be enough people willing to invest, and there's also probably a way to scale the business. I don't view going public as an exit, but viewing going public as a way to raise money to scale the business. So there's enough financial muscle that's getting built at all stages. But the question is, are there enough people funding at the early phases to fund some of these, right? That I think they have to come together. I'm on the entrepreneur side, not the venture side. I've played both, but that has to come. That's my point of the answer to Abhishek's question is, at a 10 gigawatt, it's going to be multi-hundreds of billion dollars worth, all the layers in the stack, and there should be enough investments going in. And if you look at what has happened in China, there's a different way to drive that capitalistic structure, right? They have taken a centralized model, but enable a lot of districts and regional people to go invest. Look at the cars. How many car companies are there? I'm not saying you should follow the same model, but there should be enough early stage at various layers of the stack to be invested. Opportunity, the exit opportunity exists.
Okay.
Thank you.
I think, thank you, Renu, for all and everybody who has participated. Thanks for coming, guys. We'll close the session. Yeah, so thanks a lot.